Welcome everyone to the March edition of this Exadata AskTOM office hours. Gavin and I are very happy to bring to you Cecilia Grant. She is a very senior technical person in the development organization, a performance architect, which means she is the person we all look to understand performance issues and to, of course, solve them. And she just published a very nice blog, just say Oracle blog Exadata and you'll land on it, where she offers her top 10 tips for performance tuning. I should say at the outset that we have a bias towards Exadata for a number of reasons, in particular because, of course, it's the most advanced technology we have. But a lot of what she has to say applies to tuning databases in general. So don't tune out if you are not centrally interested in Exadata. And the most important thing, of course, in these office hours is to give everyone a chance to reach people that normally are out of sight because they are very, very busily working on our technology, and to get an understanding of why and how we do things.
First met Cecilia, well, as I joined early last year, and one of the first things I realized was that Cecilia was a very smart person and knew as deep as you needed to get into the database, which was fantastic as I was obviously coming up to speed. You know, I worked with Cecilia and encouraged her to present at Open World last year, and it was a very good session that she ran in the theatre style, and that was the top 3 tips, I think, yeah. Cecilia?
Yes.
Yeah, it was like, well, how about 10 tips to discuss, you know, around performance tuning? And yeah, it's great to have you on, Cecilia.
Great. Thanks for the intro, Gavin and Krish. So as most of you heard, basically I got roped into this by Gavin. So, but yeah, so I guess let's get started.
Yes, let's. I'm showing the obligatory disclosure, by the way, and I think now I can ask Cecilia a first question to warm people up. I looked at the 10 tips as we published them, and I thought, okay, fine, great, 10 tips. That is too much. Can you tell me about 1 or 2?
Okay. Can we make that 3 now? Just
Sure. If you like.
I guess the very first thing that we always say is let the data guide you. We have a lot of performance data available. There's AWR, there's SQL Monitor, there's ExaWatcher, there's cell metrics, there's a whole host of information available. Let the data guide you. We see time and time again that people, especially when they're on Exadata, it comes to us saying, we're on Exadata, therefore it must be an Exadata problem. And at that point, it may be a fair assumption, especially if they're comparing non-Exadata to Exadata, but you really need to let the data guide you. That's what it's there for. And when you look at the data, don't just look at it to try and support what you think is happening, but also look for things that could potentially disprove what it is you think is happening. And that way you'll immediately know if you're on the wrong track. Okay, so I guess that's one of the top things is make sure you look at the data. And secondly, the database tuning methodology, it really doesn't change on Exadata. You're still supposed to look at DB time, address where your time is being spent. That really doesn't change. We do offer different solutions on Exadata, but the bottom line is as far as database tuning is concerned, DB time, where your time is being spent, look at your wait events. Those are the ways to address your performance issues. And just one more thing, which it was in the Oracle Theater session, keep good baselines. Whether that's your peak periods, a month end, or say a batch job, just keep good baselines. And by that, don't just look at the AWR report, but actually keep the raw data. So AWR, ExaWatcher, cell metrics. And that way, if you do have a performance regression, you have something to compare it to. And that's especially important if you end up with a performance regression and you have to file an SR with Oracle, because you may know what's normal on your system, whereas we actually have no idea what your system is supposed to look like. So by having a comparison point of the bad period versus a good period, it allows us to immediately focus on where the differences are, and it guides our investigation so that we can quickly come to a resolution. if you need to take away things, it's those three. Focus on the data, database tuning methodology doesn't change, and keep good baselines.
Oh, thank you. That's great. Let the data guide you. In other words, be a good scientist. Don't look for confirmation. Just be open to the data. Don't get confused about Exadata being different. It's still the database, and those methodologies apply. The tools may vary. And keep good baselines, which is the prevention part is the thing you do before you need.
The idea of keeping good baselines is very important from that point of view. You know, I started working with Oracle many years ago and was around when Exadata first came out. And I remember working with some Oracle consultants saying that, yeah, we just move it across to Exadata and we don't care about any kind of performance tuning. It just runs fast. I think as DBAs, we should be always striving for the best use of the resources that we have. Would you agree?
Yeah, we've certainly seen a lot of cases where you can get away with a little more on Exadata just because of the features that it has. For example, we've seen cases where people think they don't need indexes because everything's a smart scan. And there was actually one customer, I think this was a few months ago, where they had an issue and they were on Exadata, and we started looking at some of their data, and we realized that they were getting over 99% of savings from storage index, which is just unheard of. And after a while, we realized, wait a second, should they be maybe building regular indexes rather than relying on Exadata to filter everything out? But we've also heard that from other consultants, that they're having a harder time getting people to write good SQL and design proper database schemas because it just works for the most part. But when you start hitting limitations, it's usually better to try and avoid that to begin with rather than waiting until you hit those issues.
And just to quickly jump on that, the idea of a storage index, can you just give the definition of what a storage index?
Okay, sorry. Yeah, a storage index, basically, if you think about it, the best type of IO is the IO that you don't do. So a storage index is metadata that we build on the storage layer so that we have an idea of what data is in a region, where the region is typically 1 megabyte. So in the simplest case, we tell you what the min and the max value of a column in that region is. So say if you query where month is less than January 2020, we immediately can see in the block, will this block contain any data in that range? If not, we don't even bother doing the IO. So it allows us to remove a lot of the IO on the storage side.
Yeah, and so it's built by the storage server itself. It's ephemeral, correct? And so if a storage server is taken down and brought back up, does it need time to rebuild that storage index?
That's correct. So it is in memory. So if you do bound cell serve, it will need time to warm up those storage indexes again.
And so the idea of the usual indexing is still relevant then?
Yes, it is, because that's persistent and it's still faster if you're getting it from the database and the database doesn't have to request the IO. So even that's still less CPU overall, that's less cost overall.
Yeah, there's a soundbite right there. You know, you just said a couple of seconds, the best type of IO is IO you don't do. And that's actually quite profound. Especially when it comes to performance tuning, it makes a lot of sense.
It's a design principle, right?
Yeah.
Yes. So you've been asking about keeping a baseline. So for AWR, you can keep baselines. You can either export the data. There's a script in RDBMS admin called AWR EXTR. So that will export the AWR data. And there's also a way that you can mark certain snapshots as baselines using the DBMS workload repository package. And that will basically prevent those particular snap IDs from getting purged from AWR. I hope that answered that question for the baselines.
I heard that Oracle does not advise to use IORM.
It's actually on by default, and you really can't turn it off. There may be ways you can change its behavior if it's causing problems, but there's no real way to turn it off. And if you do need to control certain aspects of your IO, especially if you're hosting multiple databases and you want to give them different priorities, it is still a good idea to set IORM plans. The way you allocate flash cache, the way you want your IO distributed. If there's databases with higher priority, it's still better to use IORM. And if you run into issues with it, then those are things that we need to fix.
Okay, so IORM is input output resource manager. So it's the ability to manage the way one or many databases access the storage and get access to the resources from the storage. So what you're saying is that if you are consolidating or if you have many databases running, it's a good idea to start creating plans and service levels, I suppose you'd call it, for the database sooner rather than later. So if you have just a couple of databases, then you would set up that plan, and then as you bring in more, you would just apply the plan. Is that?
Generally I think that's what customers do. They usually have different tiers, and then when they bring on a database, they just figure out which tier in their IORM plan it belongs to.
Right. So I suppose if you've got an OLTP or some kind of commercial application running, then you would have the highest tier for that. And if you've got batch or warehouse or something, it would have obviously a different profile for storage because it'd be accessing in a different way, and therefore a different kind of tiering or different kind of plan. Yeah.
Right.
Okay.
It says AWR reports in specific cases show some Exadata disk I/O bandwidth and IOPS metrics in red, showing these outliers as over maximum limit, and this could be for only a few hard disks, not all. How to best interpret these outliers?
Outliers on Exadata, first of all, make sure it's an IO problem. If you're not seeing IO problems, don't even look at the Exadata IO sections. If it is an IO problem and you are seeing outliers, so if it's dark red, that means it's over capacity. It's very rare that it would only be on a few disks, because we typically expect the workload to be distributed evenly across all your cells, across all your disks. So if only some disks are hitting the max and the others are completely idle, well, I guess it depends on what the difference is, but it's not normal to see that. So if you're seeing something like that and you're seeing performance problems, when we've seen it, it tends to be something the database is doing. In one case recently, we saw exactly what you had mentioned, that there was one cell which was extremely busy. It wasn't on hard disk, it was on flash at this time. And it turned out the database was rereading the same lob segment over and over again. That's why it was only concentrated on a few disks. So it normally isn't just going to be on a few disks. If you're reaching max capacity, it tends to be on all disks, in which case you need to figure out why it is you're hitting the hard disks that much. It's a bit more difficult to answer without seeing the data in this case, but
but that kind of goes back to your top three. Look at the data to what you're seeing as a performance problem, and kind of chase that through and look at where the database time is being spent. So kind of as a self-help for that is to basically chase through using AWR and digging into where the database is spending time.
Yeah.
See, I'm a performance expert now. Look at that.
Yes, learning quickly. Right. So I see there's another question there. Is there any SQL that calculates how much workload on Exadata is reducing I/O or performing faster compared to non-Exadata machines? Reducing I/O we do have. So we see the storage savings. So if you're doing smart scans, we have the storage index savings as well as the CC, which is columnar cache savings. That's in the AWR report. So those are the IOs that you did not have to do. So it's a more general number. There are other benefits. In the SQL Monitor report, we also have the cell offload efficiency number, although that one, we've had problems trying to come up with a good formula for that because of the various things that we've introduced, like, as I said, SI, CC, compression. So doesn't always give you a good number. As far as comparing it to non-Exadata machines, I don't think we really try and show that to you. You can see how much we're offloading, and I guess the amount, basically when you see how much was eligible for offload versus how much we're returning, that's basically savings that you can get on Exadata that you can't get on non-Exadata machines. Okay, the next question. Will customers be able to or need to run AWR reports in autonomous database, considering they are locked down? Are there different approaches to performance tuning on autonomous? So for autonomous, you do still get an AWR report, but it's restricted to data on that PDB. The Exadata statistics are not at all visible in autonomous for a PDB tenant. The idea being that layer of the stack should be handled by us, Oracle, our cloud operations. So the data that you get to see is things that your application is doing. So top SQL, top sessions, your workload profile. So you do have an AWR report, it's just much more cut down.
So in terms of performance tuning on that, I suppose it would come back to write good SQL and things like that, you know, building the indexes that you need, knowing that underneath you've got things like storage indexing happening, but to kind of, you know, have a good schema architecture, have good SQL, things like that, yeah?
Yes, and yeah, so it's concentrate more on the upper level, the application side, rather than all the configuration issues, database storage, that should all be handled by cloud. So you shouldn't have to worry about that piece.
Yeah. So just kind of related, and this is more, you know, the whole key and nothing but the key, and the idea of the third normal form and things like that. Is that still relevant in today's schema architecture and, you know, relations between table, or is there somewhere that we should be looking for the best way to architect your data?
I think that's a valid, the normal forms. The only thing that you need to worry about there is, depending on how often you do joins, sometimes it may be better to denormalize, especially if you start going to a warehouse environment. You'll have duplicate data, but it's faster because you don't have to do the join. But also, don't look at just the model itself, but also think of how the access patterns. And that'll help you figure out what the data should look like and how you should structure the data. Can
you just explain that bit? Access patterns.
Access patterns in terms of, is your data selective? Do you think you're going to be going after it via a selective column most of the time? Or do you think you're going to be joining to it? How much of the data you're going to be accessing? And what other tables you think you're going to need? There was one in particular, which in a group I was in before. I don't know if I should say this or not. But
maybe protect some names.
that means we should. Absolutely. That's why we come here. So you say these things.
So I was asked to help tune SQL for this particular app. And so every so often I get all these SQL, look at the schema. So you'd always look at the schema, the tables it's accessing versus what they're trying to do. And there was one area where they had this pages and pages long of SQL. And I had asked them, okay, can you describe the model? What's the schema? What's the SQL trying to do? And I was just told, we can't, it's too complicated. And so that was already a red flag. If the model is too complicated, there's no way you can write good SQL with it. So it's just one of those things. I think I've used that up. It's too complicated and you can't describe the model. That's probably a good indication you should go back and relook at what you're doing.
Yeah. Okay, let's have a look at a few more questions. What would be the benefit to run Exadata X8M with persistent memory in write-through mode instead of write-back? So I should get Cecilia to describe what those two modes are. Maybe from a Flash point of view, that's an easier description, and then why and what the PMEM version is looking like.
Yeah, so from a Flash point of view, write-through basically means whenever we do a database write, it has to write to disk, and then once it finishes the write to disk, it populates Flash. Okay, write back means when we write from the database, it lands directly in Flash. So PMEM is very similar as well. So write through means we will write to flash, because you have write back flash cache, and then we populate into the PMEM cache. Whereas write back means we will write directly into PMEM cache. And Gavin, you already mentioned use write through, don't use write back for PMEM. Well, there's plenty of reasons, but from a performance standpoint, you don't really need the write back functionality of PMEM because the writes from the database are asynchronous, specifically the database writer writes. So users don't tend to wait on that. That's a background task. That's asynchronous. Whereas the reads are important. So getting write back on PMEM is not as important. So for performance reasons and for other reasons, stick with write through for PMEM.
And that's different from Flash because you can have a grid disk on Flash that you could write to. Am I in the right area for that one?
Flash, we don't encourage people to build Flash-based grid disks.
Okay.
So write back flash cache should be enough to manage it. It's just that Flash is much bigger. And Flash, we can also reuse those cache lines. That's how we partition, or we call the pieces of storage in Flash is we can write to cache lines and we can reuse them. So we end up saving the disk IO. But in the PMEM case, Flash is already fairly fast. It's fine to just write to Flash.
Yeah, and as you said, because it's asynchronous.
Yes.
So it's not in the critical path, and therefore that extra delay of going straight to Flash, not through PMEM, is fine.
Is the PMEM cache write through by default?
Yes, it is. There's a question, is there a new feature planned on PMEM in the cells?
Oh, new features.
The whole PMEM stuff is completely new, so I'm not quite sure how to answer this question. Gavin, do you want to?
Well, we as in Oracle continue looking at old technology, and all hardware is looked at and scrutinized. And last month with Jia, talking about persistent memory and the work that we're doing with Intel of looking at how to best use persistent memory. And Jia mentioned last time that we used persistent memory in the best possible way. So being able to have that as shared storage or shared persistent memory across the entire storage tiers was the number one goal. So, we've used persistent memory in that precise position because it is the best architecture from a storage point of view. As we look at how to use persistent memory going forward, obviously there's going to be different workloads or different use cases that we could use it in. So I'm sure we haven't seen the last of persistent memory, but in terms of precise details, obviously we can't go too much into futures. So Cecilia, how did you get into performance tuning? Did you just land in this, or was this something that you've kind of chased as part of your career?
No, I actually accidentally landed into it. I was looking for a job coming out of grad school. I interviewed at Oracle, and I was hired in what was then the customer benchmarking group within development. Okay. And since then, I didn't know what I was doing then, but I didn't realize how fortunate I was to be working on always the latest releases and the newest hardware from the various partners and vendors. So when the opportunity came to join the Exadata group, I just said, yeah, sure. Good technology. Why not?
Well, yeah, and all that experience of working on customer benchmarks would have helped in the early years of Exadata for sure.
Yes, and that prompts me to ask two related questions, Cecilia. You can pick one or both. One, you said you didn't know what you were doing when you came out of grad school. What was your education? What did you bring, and what do you have to learn later to become functional in this area?
So my background was computer science, databases and systems. I think the statistics would have been better, especially if you're trying to do long-term capacity planning, data mining. But for just performance in general, I think just being methodical and analytical should be sufficient. Just think logically, how does this work? Comparing two numbers.
Great.
And just being analytical.
That's very helpful, and that means anyone who is interested in systems can get into this. But tell us a little bit more about the relationship between the real life experience of customers and serious large production critical deployments, all the way into the people who build the systems, write the code, going through configurations and best practice and so on. Talk a little bit about that.
So basically, the Exadata development team, the development group itself is not that large, but there's a huge extended team that we work with. So there's the MAA team, there's X team, sustaining engineering, stress testing, system testing, the performance groups. There's a lot of people that we interact and work with on a daily basis. And it all basically flows back into the development cycle. So whatever the people are seeing, especially the MAA team and the X team, when they work with customers, what they're seeing, that all goes back into development so that we can make sure that we improve our product. And same thing when we get escalations from support, that goes from support to sustaining engineering, it does come back to us as well. And so that all gets fed back and to make sure that we continuously improve our product. So it is a fairly large team that's a lot of rigorous testing, and we can't test everything. So then when there are escalations that come in, we also get the stress testing team involved to see if they can reproduce this scenario. And so we can analyze it more closely within the development groups. So yeah, it wouldn't be as successful as it is without the help of all these other organizations within Oracle.
Excellent, thanks. That's great.
If I'm not running on X8M, so PMEM isn't available, I can still use storage as RAM and RAM cache features with RDMA, but over IB instead of Rocky. Does that always accelerate reads, or only if the buffer cache is under pressure for reads?
Will still accelerate reads. It won't be as fast as pure PMEM, but the ranges that we were seeing, normally if you had flash, you're at about 200 or so microseconds. If you're at PMEM, you tend to be much lower at about 20 microseconds. If you still have to go through IB, then I think you can be at around 100 or so, 100, 150 microseconds.
Do you have good websites to recommend for connecting the Exadata tuning experts, or good articles on Exadata performance tuning?
The white papers and presentations that are published by the MAA group and the X team, those are generally very good articles. In terms of other sites or connecting to Oracle experts, the Oracle PMs or even individual contributors that are within the database development group, those tend to be good sources of information as well. So I'm guessing most of you have already heard of Maria Colgan, SQL Maria. There's the Exadata blog as well. Those are good sources because they're going to be very accurate in what they're saying.
Yeah, I've also noticed that the user groups are very active, kind of encouragement for the people on, listening in. If you've got something that you've found or some knowledge that you've gained that you think is, worth sharing with others, then the user groups, I think, are a great way of getting that information out and discussing and actually chatting about this. And obviously, as Chris and I continue to do the office hours for Exadata, feel free if you have ideas or if you want to just have kind of an open mic night on the office hours, we can look at that as well.
Back in the day, the focus was use 10046 traces of an application function and use the wait states to identify where to tune. The question was, do the methods we've used for years continue to hold? For the most part, yes, as long as you understand the changes in technology. But one thing I would caution about 10046, there are other tools like SQL Monitor right now, which give you much better information than SQL Trace. And there was a recent escalation we actually had where they were comparing non-Exadata to Exadata. So they said it's an IO problem. They did SQL Trace. SQL Trace was showing all the weights were cell single block physical read, which is pretty much an IO. And so it went through support, it went through sustaining engineering. They said it's an IO problem because that's what the weight said. So we looked at it, sustaining engineering said all the IO latencies look to be good. They're well within the range, everything's going to flash. So we then took a step back and said, okay, what's happening? Let's take a look at the AWR report. When we looked at the AWR report, it said over 98% of the time was on CPU. SQL Trace doesn't show you that it's spending time on CPU. They took a snippet of SQL Trace. They never ran tkprof on it, but most of the time was actually CPU, and IO was such a tiny portion of their workload. And then it turned out it was because it was doing row by row processing, which is why it was burning all that CPU. So SQL Trace is there, but always cross-check the other data sources because sometimes it'll show you something different. So in that case, had they looked at AWR, SQL Monitor, even tkprof, Ash, they would have all shown that your problem is really CPU and not the weights.
Yeah, I like that one. Because and it kind of, you've mentioned this in the blog around multiple metrics and making sure that you're looking at where the time is being spent. I suppose that was your second point today. Yeah, look at where the database is spending all its time. So CPU, yeah.
For storage index, can it be stored in flash cache for very frequently used storage index? I dare say no.
No. Storage index currently is purely in memory. So I'm saying currently. So it's purely in memory.
Thanks.
Attendee. We have increasing logfile parallel write on Exadata X8M database. Over time, it went from 0.2 milliseconds to 1.2 milliseconds. What can cause this? That one, I guess, goes back to keeping good baselines. So if you have the baselines for the 0.2 milliseconds and then compare that to the 1.2, that would give a much better idea of what could potentially be causing this. I can only speculate at this point, which I normally don't like doing, but it probably has something to do with how your hard disks are now. It may have something to do with how your hard disks are busier now. But again, look at your baselines and compare and see where the other areas of differences are, and that may actually explain why you're seeing a regression in your log file parallel write time. It says, I knew the storage indexes is the best thing to have, but how to push the queries to use the storage index? The storage index will get built automatically, so you shouldn't have to do anything. It's based on the distribution of data in the table. So if it looks like the data is fairly clustered, we will build a storage index on it. So if you really, really want to force it, you may have to play around with how you load the table to begin with, which normally isn't realistic for a production environment. The data will come in naturally if it's naturally clustered or not. If it's naturally clustered, we will build a storage index on it.
Yeah, I think there's a whole science behind that, really, isn't there? I've had a few sessions with Cody talking about how storage indexes and the idea of that clustering, as you mentioned. I think that's a session in itself to dig into the details of how that works.
And there's another question on storage index. Is the storage index spread uniformly across all cells? The shutting down one cell to remove all storage index information. The storage index is actually built, it really is dependent on the data in that region. It may not be identical across all cells. It may not even be identical across the same regions or different regions within the same cell. And while shutting down one node, you'll lose the storage index information for only the node that you're shutting down. So data that you're scanning on other nodes should still be able to use the storage index. And I'm fairly sure we've released this, I just don't remember what release, that if you do shut down a node, we can also move the storage index to the secondary copy so that you don't completely lose it if you end up having to scan the mirror of that data.
We're going to stop here. So I wanted to encourage everyone to post your follow-up questions on the AskTOM system. Please suggest to us topics or areas or people you would like us to invite. I wanted to especially thank Cecilia and my colleague Gavin, and I will let them have the last word.
The last word. No, thank you. It's always great to get experts on the phone, and Cecilia has been an amazing input into my work here in product management, and yeah, the continued success of the product is because of people like Cecilia. So thank you for joining us.
Thanks, Chris and Gavin, for giving me this opportunity. It's always interesting to see real customer workloads and how they're using our product. So that's always interesting.
Excellent. Thank you, everyone.
Thanks, Chris.
See you next month.